Unit 2, Lesson 5, page 2. Students will be able to identify the slope of a line given a parallel or perpendicular line. So skill 1, let's identify the parallel lines using the property of the slope. Parallel lines have the same slope if the degree of slant or type of slope, positive, negative, 0, undefined, if the two lines are identical to each other, then the two lines are parallel. They will run alongside each other at the same distance apart and never touch. So if you have a grid and you have a positive line going like this with a particular slope, then you will have the same amount of tilt all the way along. It'll run along and keep the same distance apart. And if this slope here is 2, then this slope is 2. So by definition, calling these two lines parallel means that they have the same slope. Telling you they have the same slope translates into meaning that they are parallel. Okay? So here's an example. Find the slope of the line that goes through these 2 points. So remember, given any 2 points, you must use the slope formula. Find the slope. And then find the slope of these 2 lines. So we have a slope of positive 2 and a slope of positive 1. The slopes are both positive, but they're not the same slant or tilt. So therefore, they are not parallel. Okay? Example number 2. We're given 2 equations, linear equations. This one is in slope-intercept form, so what's the slope? You can just look at it. The numerical coefficient of this term is a -2. That's where the m is. Okay, so the m, or slope, is -2. This one, however, is not in the proper form for me to see that. So we need to move this into slope-intercept form. And we can see that that is now the slope, which is a +2. Are these 2 lines parallel? No, they are not, because one's negative and one's positive. So they would cross each other like an X on a graph. Definitely not parallel. All right, these 2 linear equations are in point slope form. So for this one right here is your m, so it's a half. This one right here is your m, so it's a half. Are these 2 lines parallel? Yes, they are. They have identical slopes. That's all there is to it, to knowing what's a parallel line. Perpendicular's got a little more to it. What does perpendicular mean? We want opposite and reciprocal slopes. Okay? Perpendicular lines are lines that meet at right angles. So if here's our graph, one line goes this way, the other line has to meet it at a 90-degree angle. So clearly one of them is positive and one of those is negative. Okay? And reciprocal is flipped fractions on the slopes. So opposite reciprocal slope. So here's an example. Find the line, slope of the line that goes through these 2 points. Well, what do we do with any 2 points? You must put them in the slope formula. Remember y2, y1, all that stuff. Find your slope is 2. And this slope for these 2, it's a half. The slopes are reciprocal and they're both positive, so it's not perpendicular. Okay? If they're both positive, they're going to run into each other eventually, but not at a 90-degree angle. Okay? So this line, example number 2, this is in slope-intercept form, so I could just look at it. There's my slope for this one. This one needs to be turned around to be able to tell what the slope is. Notice that I can't just look over here. I need to put, the whole point of the slope-intercept form is to put it in this form so you can look at the numerical coefficient and see that this slope is a 2. So positive 2, negative, and flipped, that's a yes. Okay, so 2 conditions to make it perpendicular. This is in point slope form, so that is my slope at 1/4. This is not, yeah, this is also in point slope form, so this slope is -2. Are these two lines perpendicular? No, they are not. Okay, if this was a quarter, then this would have to be a -4. Okay.